Hello, I'm Ben, and my research topic is about the chemistry behind the soda and soda cans. I chose this topic because before even starting this project, I was always curious. Why does soda fizz so much compared to the normal liquids like water? And what exactly causes it to explode when we shake the can? I was really intrigued by these questions, and it led me to explore the fascinating chemistry happening inside this little aluminum can. So first, let's explore how a soda is made. Soda is made by dissolving the carbon dioxide inside the flavored water. And this carbon dioxide is what makes the soda fizzy. If we dissolve CO2 in water, then the CO2 reacts with the H2O, which is water, and forms H2CO3, which is carbonic acid. This reaction is an equilibrium reaction, meaning that it goes back and forth, creating the carbonic acid and breaking the carbonic acid. But since this is an equilibrium reaction, it is always shifting, so you might wonder, how do we make sure the carbonic acid actually stays in the soda and doesn't just turn back into the gas? So when the cap is closed, the pressure inside the bottle is much higher than the outside pressure. So according to the Le Chatelier's principle, when the pressure increases, the reaction shifts from the side with more gas molecules to the side with less gas molecules. Since there are 2 moles of gas on the reactant side and 1 mole of gas on the product side, more forward reaction will happen. Therefore, the CO2 will be used up to create the carbonic acid, keeping the CO2 inside the bottle. Now, when the cap is open, the pressure decreases, and according to the Le Chatelier's principle that I just explained, more backwards reaction will happen for this reaction, creating more CO2. Therefore, the CO2 would increase and the CO2 would be released to the air, and is not trapped inside the bottle anymore. This really explains how the soda just feels flat if you open the cap for a long time. So, now we know that what soda is composed of and how the CO2 is kept in the bottle. Let's explore why the soda explodes when we open the bottle after shaking it. When we shake a soda can, small bubbles form inside the liquid. These bubbles act as a place and a site where the dissolved CO2 can be collected and escape as a gas. Shaking the bottle also breaks the surface tension, making it easier for the CO2 molecules to rise to the top of the bottle. Then, when we open the cap, the pressure drops. And we know that when the pressure drops, the equilibrium shifts left to produce more CO2 gas. Then, all those CO2 that are built up inside the tiny bubbles expands rapidly, and the bubbles also expands at the same time. This expansion pushes the liquid up and out of the bottle, causing the soda to explode or spray everywhere. We can go even deeper from here. Since the Gay-Lussac's law, which is P1 over T1 equals P2 over T2, states that the pressure and the temperature are proportional. As the temperature is higher, the gas inside the bottle will build up more pressure, and the warm soda can explode more forcefully when the cap is opened. There are also lots of interesting topics related to the soda cans, but right now I'll only talk about one. When we heat up the soda can and quickly flip the soda can upside down and then put it inside the cold water, the soda can implodes, meaning that the soda can crushes inwards, not outwards, as if it was put into a vacuum. So here's why the can gets crushed. When you heat a little water inside the can, it turns into the steam and fills up the space. Then when you flip the can into a cold water, the steam cools down super fast and turns back into a liquid water. And since liquid takes up way less space than the gas, the inside of the can suddenly has almost nothing in it, so the pressure inside drops really fast. This shows a phase change when a gas is turning to a liquid. According to the gas law, like the ideal gas law, PV equals nRT, if the temperature drops, the pressure also drops. So the outside pressure becomes way stronger than the weak pressure inside the can, and that really crushes the can. This is a cool example how pressure difference and phase changes work together. In conclusion, the fizz, the explosion, and the crush can all happen because how gas pressures and the temperature affect each other in simple chemical reactions. Thank you for watching my video.